Okay, so next let's look at trees. So what is a tree? So a tree is a type of connected graph, so no isolated vertices, that have no cycles. So that's the only requirement for something to be a tree. There should be no cycles. So you shouldn't be able to go from one vertex back to that vertex without repeating any edges or vertices. And no loops or multiple edges exist in a tree. Trees are also planar, and they only have one face. And that's because there should be no enclosed regions, because there's no cycles. Okay, so something that you will be asked to determine is something called the minimum spanning tree. So what is a minimum spanning tree? So a minimum spanning tree is basically when we have a graph and we're trying to determine a tree that gives the smallest weight possible for all of the vertices that exist. And I will show you an example, but I'm just going to go through the steps to start off with. And next year you'll be learning about the Prim's algorithm as well, which I will teach you this year as well, but it's not necessarily required. So what you do in order to determine this minimum spanning tree is you start with a fixed vertex. So you start with any vertex on the graph. And what you do is you select the edge connected to that vertex with the smallest possible weight. So that vertex might be connected to, 3 different edges. So one vertex might be connected to 3 different edges. And let's say there's 5, 4, and 7. Then we pick the one that is the smallest weight. So we pick that one and we just highlight it or something like that. And I'll show you an example of the sort of question that you're likely to get. So once we've selected that one, what we do is we select an edge among all those connected to the 2 vertices. Okay, so we select the vertex that it connects to, and then we, again, follow the exact same process. So we select the one that is the lowest edge. And we do this until we have drawn a connected graph. And remember, connected graph, the minimum number of edges that you need is n-1, and that is how many edges that will exist. So you should not form any cycles. That's how you can tell whether you have a minimum spanning tree or not. There should be no cycles. So here's an example. So determine the minimal spanning tree. So this is the sort of question that you're likely to get. So it'll give you a graph like this, and they'll ask you to just they'll just ask you to draw the minimum spanning tree on top of this. So let's start off with a random vertex. So I'll just start off with, let's just say this vertex over here in the corner. Okay, I'll come back to this. Okay, let's look at this vertex over here. So here, this one is only connected to one edge. So we just draw that one in. And then we just go from this vertex. So this vertex has 3, 200, 500, 400. So we select the one that is the lowest weight. This one over here. And then we go from that vertex. So this one is connected to 300, 100, 150. So we select the one with the lowest weight. So this 100 over here. Okay. Now looking at this vertex over here, it's connected to 2. 350 and 300. We just select the 300 because that's the lowest weight. So we do this one. And then we can select, maybe this vertex over here. This one has, this one has 5. So we select the 50 because that's the lowest weight. And then we select maybe this vertex over here. This one is over here. This is the lowest weight. Okay, so now we've sort of encountered a problem where we have this vertex over here isolated. Although we've connected to this vertex over here, we still need to connect it to the rest of the graph. Now there's 3 ways of doing it. We can do 400, 450, or 500. Now obviously the lowest one is 400, so we will select that one over there. And finally, one last problem. We need to connect this segment over here, this one, to the rest of the graph. And the way that we can do this is either by selecting this edge, this edge, this edge, or this edge. And again, we will select the one with the lowest weight, which is the 100. And that is your minimum spanning tree. As you can see, there are no cycles at all. Okay, so that's minimum spanning tree. I love doing these because they're so fun. I just find them a bit fun. And also, it doesn't feel like maths. It doesn't feel like I'm doing calculations or anything like that. So Yeah, so these are really fun, especially using the Prim's algorithm. Okay.